Algebra 1, linear function, visualizing function by coordinate. So we learned the type of function. Now one specific function we start learning in algebra is called linear function. So what is a linear function? So we use a coordinate to understand what the linear function is. The linear function is a function that produced a straight line on the xy coordinate. You have x and y. These are real number line. Okay? And linear function is like y equals 2x, or it doesn't have to be 2, any number, say m. Well, when you say any number, then another variable here. So you have a two variable y, m, x. But when we draw the graph x and y, then m, we cannot draw it, right? It's going to be 3D graph. It's not convenient to use right now. So when you cannot handle, you just give a fixed value. That's called parameter. This kind of variable, it's a variable, okay? X is independent variable, y is a dependent variable. And in this case, the variable m is called parameter. Parameter change, then x and y relationship change. So what is m in this case? We think about it, okay? M is called slope of function. For example, if m is 2, then x is 1, y is 2, right? So from 0 to 0, 0, x is 1, 2. This need to go through. This graph is not correct. Okay. If m is 3, parameter has a larger value, the x is 1, y is 3. So it's going to be even steeper line. Okay. So graphically, parameter m is called slope. This linear function. Again, what is a linear function? Linear function is straight line on the graph. Okay, so this is a linear function, and this straight line, how much this inclined, this slope, is determined by the parameter m. Okay, when m is negative, what's happened? X is 1, y is going to be negative, so it's a negative slope. It's sloping down instead of sloping up, right? So for each increment of x, y changes the amount of m. The parameter m is the slope of xy coordinate. When you draw the linear function on the graph xy, m is parameter and called slope. The which slope is larger, m2 or m negative 4? Well, which slope is larger? The 2 give a positive slope, but negative 4 give negative slope. When you ask which slope is larger, negative 4 is larger slope, right? Much steeper slope. Okay? We're not talking about which number is larger. Of course, 2 is larger than negative 4. But slope negative 4 is larger than slope 2. Okay? So now we come to the basic linear function basic. Let's see. Linear function basic form. Okay, the first form you learn is y equals f of x, so mx plus b. This plus b looks familiar. It's a shifted function, and y shifted, right? So what happened is m is a slope, so m determines how much the line is inclined around the coordinate 0, 0. The line is depend on m, the slope change, but if you add the b, it's shifted y direction. So it's going to be like if b is 2, function will be like this on the xy coordinate, because if shifted by 2, right? Shifted by 2. So y equals f of x equals mx plus b. This shifted function b, the shifted amount, this is also variable, so we call that parameter. Okay, so this parameter b give you how much it's shifted along the y. Okay, the parameter m and b. M is the amount of increment on y direction. It's called slope, right? B is the y shifted quantity. So when you draw the line where it's intercept with y coordinate, value b, so b is called intercept. Okay, so we have a name for the parameter m and b in linear function, y-intercept. Okay, we have an x-intercept too. In this example, you look at this. This is slope 2. If y is 2, the x-intercept is negative 1, right? This is 0, 1, 2. This is negative 1. So x-intercept is negative 1, but the y-intercept is... Okay, that's a good question. If we have mx plus b, what is x-intercept? X-intercept is when y is 0. So mx plus b is 0. And move the b on this side. Did you get used to this operation? Negative b. So x-intercept is minus b over m. Okay, so x-intercept is going to be given by this. If we know the value of b and m, those parameters, then we know the x-intercept. Okay. So linear function on coordinate system. Now suppose this is a function, but we don't know m and b, but we know it's go through the coordinate point a, which is given by x1, y1, and the coordinate b, which is given by x2, y2. Then the slope is going to be y2 minus y1 and x2 minus y1. Slope is going to be the ratio of this, right? And once we know the slope m, we can find out the b, because y1 minus x1 is going to be the slope. The b is going to be what? y1 minus, we know slope x1, right? Because y1 equals mx1 plus b. This is the original equation. So b is given by this. So we plug in m to this equation, then it's going to be like this. So with the information that two coordinate is given, y1, and another point x2, y2, 2 points are given. The line that goes through these 2 points, the linear equation is going to be y equals mx plus b, and m is given by this, and the b is given by this. Okay, so we can determine the linear function equation once we have information of 2 points. It's a line. You need at least 2 point information to determine the line. Okay, 1 point determine only the line that goes through that point, but you don't know the slope. So if you have a 2 point, the slope is easy. y1 minus y2 minus y1 over x2 minus x1. That's a slope. And once you know the slope, you can determine b too. So you can completely determine the linear equation once you have 2 points. Okay? Calculate m and b for the given point a and b. So this one, m is 6 minus 5 over minus 2 minus 2. So negative 11 over 4. Then you put the b, this formula. So this is unknown value. You have so many unknown value, but unknown value is given in the question. So you just plug in those unknown value, right? Then you get this. So linear function m is negative 2. It's go through. Okay, now this time it's a challenge question. The slope is given and 1 point is given. So it's like 2 and minus 4. This point, the linear equation goes through this, linear function goes through this, and slope is negative 2. So it's negative 2 is like this, right? So how do we determine? Okay, y equals mx plus b, right? And slope, you plug in this one. Okay, and x and y is given. So x is 2, and this is not negative, that's wrong, negative 4, right? Then b is 0. This answer is wrong. Okay, you have to look at this. Negative 4. Why is negative 4 when x is 2? So you plug in x and m is negative 2. So b becomes like this. Negative 4 divided by negative, not divide by, sorry. Negative 4 minus negative 4. The same value you subtract, then it's 0. So b is 0 here, x and y. It should look like this. Okay? So linear function, you can write a different way. Suppose you remember intercept b, intercept is a for xy coordinate. The reason is this has a m negative b over a, right? Okay, so y equals negative b over a x, and the y-intercept is b. Okay, so if you change this equation, right, y plus b over a x equals b. You divide b on the both side, b 1. Okay, so it's become like this. Okay, so intercept coordinate, this look like x is 0, so this is the y-intercept. Okay, this y is 0, this is x-intercept. So this one plus this one equals 1. Easy, right? So when you know the intercept, equation can be written very easily. Okay, so that's another form of linear function. This proof here, we already did this. Okay, now you may wonder what's happened to the 3D domain. You have a coordinate x, y, z here. Okay, x, y, z, and this intercept formula is very convenient because when you have x, y, z, intercept is 4, 3, 2. This linear plane, it's not a line anymore, plane. Equation is going to be using intercept like this. It's very easy to remember, right? Okay, so say if x is 0, means yz plane, we have a linear line. It's going to be only, this is 0, x is 0. We take only this part. We give a linear line. Okay, if y is 0, this linear line. When z is 0, this is a linear line. Okay, linear function. So linear function on each plane. This form tells you it's include all linear equation. So it can be the 3D linear equation. What is a linear in a 3D? Well, it's a flat, straight plane. That's a linear plane. Okay, 3D, it's not a line, it's a plane, and it's flat linear plane is a definition of linear function in 3D domain. Okay, well, I think you learned everything about linear function. You do a lot of practice, get used to it, then you are expert in the linear function in Algebra 1. Okay, thanks for listening.